Hello guys and gals, welcome to our class video where I will show you a couple examples of how to apply limits to piecewise functions. Our learning goal is that you can determine the limit of a piecewise function at the endpoints of its subintervals. That I mean by that where the pieces switch over, like it switches from this piece to that piece. Anyway, alright, let's get started. But first, here's a quick review of some concepts about limits and limit notation that have either included in previous videos or we will talk about in class. If you see a little negative sign inside a limit as x approaches c and then a little negative, that means the limit as x approaches c from the left. If you see a little plus sign, that's the limit as x approaches c from the right. Okay? If those two limits are not equal, then we would say that the overall limit as x approaches c does not exist. And f of x must approach the same y value from both the left and the right. There's some other reasons limits might not exist. One of them is unbounded behavior. That's when the function value approaches an extremely large number or an extremely large negative number. That might be, for example, be a vertical asymptote. Okay, and there's also the case of oscillating behavior. That's too complicated for me to put a summary of right here, but we will talk about it in class. Okay, so let's consider this first piecewise function here. I've chosen some pretty simple functions for its pieces to help you grasp the concept a little easier. But the thing you want to pay attention to the most on a piecewise function is where it's going to switch pieces. Or it's going to switch from the first piece to the second. Here it's going to switch over at x equals 0, and that is right here. So that's where I'll know I need to jump from one piece to the next. Alright, so let's consider the limit of the function f of x as x approaches 0 from the left. That's that little negative sign. So let me ask you, the viewer out there, to think about which one of those two functions, x plus 1 or x squared, is the one that applies on the left. Were you thinking this one? Okay. The x plus 1 function applies on the left because that's where x is less than 0. Less than is on the left side, left hand less than. So that's the left function. And similarly, the x squared applies on the right of x equals 0 because that's where x is greater than 0. Okay, so let's draw a graph of this function to help you understand the limits. Okay, first we got a graph of x plus 1. That's a linear function, has a y-intercept of 1, so I'm going to put a little point right there. And it has a slope of 1, so that would go like this. Okay, but just on the left-hand side, of course. Then x squared applies on the right side of that line. So x squared is our basic quadratic function, a parabola. It's going to start at 0 and have an open circle because there's no equal sign underneath the greater than sign, and follow the basic parabolic trajectory through the coordinates 1, 1. Okay, we've got a graph. Now we're ready to consider our two limits, or three limits. Okay, so what would be the value, do you think? Again, I'm asking you, the viewer, to think about this. As x approaches 0 from the left, what is f of x approaching? Were you thinking 1? As x approaches 0 from the left, the y value is approaching, getting closer and closer to 1. Right? You could also have determined this by just simply substituting in 0 into the left-hand function. 0 plus 1 is indeed 1. So then, again, you, the viewer, what do you think about the limit as x approaches 0 from the right? Okay. Were you thinking 0? As we're coming down the parabola from the right, as x approaches 0, the y value is getting closer and closer to 0. Note that it doesn't matter that there's an open circle there, and the y value at x equals 0 doesn't matter. It's just what is y getting closer and closer and closer to as x approaches 0. Okay? Similarly, you could also have plugged in 0 to x squared, and 0 squared is 0. Okay? So then, what is the overall limit as x approaches 0 of f of x? Think about it for a sec. What would you say? This limit does not exist. So notice I crossed out the equal sign because you can't be equal to a set of words. Technicality. This limit does not exist. Why? Because 1 is not the same as 0. Okay? To more formally state that, if you needed to justify why the limit doesn't exist, you could say because the limit as x approaches 0 from the left on f of x is not the same as the limit as x approaches 0 from the right of f of x. That's a very short and succinct way to write it using those symbols. That's basically that's a mathematical sentence right there. Okay. So, we've given you a basic one. Then let me show you another one that's a little more difficult to understand. So let's consider the limit as x approaches 0 of the function the absolute value of x over x. Okay? You notice if we directly substituted in the 0, the function value would approach the indeterminate form 0 over 0. However, hold on a sec. Isn't this video supposed to be about piecewise functions? Is this a piecewise function? Well, yes it is. Here's the graph of the absolute value of x, and it's composed of two pieces that you switch over at the line where x equals 0. So we could rewrite the absolute value function in its two pieces. I have one piece where x is less than 0, and then I have another piece for when x is greater than 0. What are those two functions that go there? Okay, well, let's start with the easier one. So you, the viewer, tell me what would be the function associated with that line there on the right side. That line is y equals x. Slope of 1, y-intercept of 0, it's just y equals x. How about on the left side? What do you think? That line is y equals negative x. So I can fill that in here. There. That is the definition of the absolute value function in terms of a piecewise function. Okay? Except for one little thing, I need to add the equal to under the greater than or the less than. It wouldn't have mattered, just so that it's has a point at x equals 0. There's the absolute value function. It's a piecewise function. So now we can go from there and transition to, okay, well, what is this absolute value of x over x going to be? It's also going to be a piecewise function. To get there, I'm going to just simply need to take the absolute value function of each piece of it, and divide it by x. So what would negative x divided by x be? Well, that would be negative 1, as long as x isn't 0, but just cancel out the x's, I'm left with negative 1. What about if I divide x by x? That would be positive 1. Okay? So now we have a piecewise definition of the absolute value function from this question. You could also verify this by plugging in some numbers. Okay? So let me just plug in some sample numbers. Absolute value of 2 over 2. Well, that's 2 over 2, which is 1. The same would apply to absolute value of 1 over 1 or absolute value of 0.01 over 0.01. Either way, you're always going to get an x value of 1. Those are from the right side of the absolute value of x over x. How about the negative side? Well, if I plug in negative 2, absolute value of negative 2 over negative 2 there, I would have positive 2 over negative 2, and that would lead me to negative 1. Okay? Same would apply if I plugged in -1. Positive 1 over -1 leads me to -1. If I have absolute value of -100th over -100th, it would be positive 100th over -100th, and that would be -1. Notice I also picked values that were progressively approaching 0 from both sides. It's basically like I just made a table there. Okay, so now's the time for you to decide what value is this function approaching as x approaches 0 from the left, from the right, and overall. Pause the video real quick, decide what those answers would be, and then come back. Alright, let's see how you did. Okay. The limit as x approaches 0 from the left of that function is -1, because the -1, or x is less than 0, is the left side of the function. You could also tell from all the values that we chose here that were prior to 0, approaching 0 from the left. Okay? The limit as x approaches 0 from the right, it would be +1. You could tell that because x is greater than 0 would be the right side of the piecewise function, or you could look at the values that we got from plugging in values approaching 0 from the right. So what about the limit as x approaches 0 overall? Well, just like the last question, this one doesn't exist. And again, -1 is not the same as 1. The limit as x approaches 0 from the left is not the same as x approaches 0 from the right. Hence, the overall limit doesn't exist. Let's look at a graph of this function now to verify our answers are correct. If I want to graph this, okay, it's a constant function of -1 when x is less than 0. So that simply looks like this. And if x is less than 0, then y is just a flat -1. Okay? For the right, as x is greater than 0, y would be a constant value of +1. You could see as x approaches 0 from the left and the right, they're not approaching the same y value, hence the overall limit wouldn't exist. Well, darn it. After looking back at the two examples I chose and doing all the work for this video, I just realized that both of the two examples I chose were ones where the piecewise function switched pieces at x equals 0 and where the final answer, the overall limit, did not exist. I want to show you an example where that's not the case, so I added this example here to the end of the video. You don't have to write it down unless you want to, if you think it would help you, but I'm just going to run through and just show you real quick what one of these kind of functions would look like. Here we're switching the pieces of the function at x equal -2. Okay? And if I want to evaluate the limit as x approaches -2 from the left, I'll plug in -2 to the left side function, and that would get -2 plus 3, it would be 1. If I want to evaluate the limit as x approaches 2 from the right, I would be plugging -2 into the right side function, and -2 plus 1 is -1, and -1 squared is +1. So here on this example, the two y values as x approaches -2 from the left and the right are the same. So the overall limit as x approaches -2 of f of x is 1. This limit does exist. You could verify that by looking at a graph. Here's a graph of that piecewise function, and you can see the point where it switches pieces at x equal -2, and that those two pieces meet together and have the same value of y equals 1 at that point. Hope that helps. Alright, y'all have a great day.